Let's see another question. Suppose you want to invest some amount of money so that in future, in 2 years, you get $5,000. Assume you can earn 12% compound interest continuously. So how much will you need to invest? Okay, so now this y is the amount you're going to get after a certain amount of time. So y is equal to y naught exponential rt. Okay, so from this we know that the r is equivalent to 12%. This is equal to 0.12. Okay, so at the end of this, you want to get the value, which is the y is equal to 5,000. So this is a reverse question. We need to find what is the y naught. So from here we get y naught is equal to y divided by exponential rt. So this is equal to y exponential minus rt. Okay, so y naught is equivalent to y is 5,000, exponential r is 0.12. So we know that after 2 years we will get this amount, 5,000. So how much we need to invest? So you need to invest this amount of money, 3,933.14. Okay, so this is the amount of money you need to invest if you want to get 5,000 in 2 years with 12% compound interest. Let's see a compound interest problem. So we have $1,000. Okay, so this $1,000 is invested at 5% interest and is compounded continuously. So question A determines the YT. What is the YT? YT is the balance in your saving account at the end of time T. So where T is measured in years. So we need to find what is YT. So question 1. So we know that the rate of change of the money that we invest in the banks follow these equations, which is RY. R is the 5% interest rate. Okay, so R is equal to 5% interest rate, which is equal to 0.05. So we need to find Y. So we do the integrations on this. We separate it, make it a separable. Make it separables. So we integrate on both sides. Here we have C. So integrate of 1 over y, we get ln y. And then here we get RT plus C. And then we're going to multiply the exponential on both sides. Then we get y equal to exponential RT, exponential C. So we can rewrite this C, this one as one symbol. So that means we have y is equal to C exponential RT. Okay. So in that case, we're going to use some of the initial value problem here. Okay. So in this, we will be given at the initial time at t equal to 0. We have the saving account value, which is our invested value, 1,000. So we're going to substitute here in these equations to find what is the C value. So y equal to C exponential RT. So y equal to 1,000. And yet C exponential R is equal to 0.05 multiplied by 0. So now we know C is equal to 1,000. So that means y of t is follow this 1,000 exponential 0.05 t. So this is our answers for question A. Okay. Now we see questions B. How much will be in the account after 6 years? Okay. So we go for questions B. Okay, so that means at time t equal to 6 years, we want to find what is the money we have in the bank. Okay, we define this one, right? So we're going to substitute this. Now we know that y is follow these equations, exponential 0.05t. So we substitute the value of this year to 6 years. Okay, and then we get this amount of money. So our value is increased. That's a good thing. From 1,000 to 1,349 and 86 cents. Okay, so that is C. Okay, now we see C. Okay, after 6 years, at what rate YT will be growing? Okay, we want to find the rate YT growing. Okay, we'll find the rate Y of T growing. Okay, so there are two methods to solve this. Let me introduce the first method. Okay, so the first method is that we have y given here is 1,000 exponential 0.05t, right? So we take the derivative of this. That means we take y prime, then this one will equal to 1,000 times 0.05 exponential 0.05t. This is the y prime, right? The rate of change. So here we get a 50 exponential 0.05 of t. Okay, so after 6 years, right? So we want to know after 6 years, that means after t equal to 6 years. So we substitute into these equations, which is 50 times exponential times t equal to 6. Then this gives us the rate of change. Okay, this is 67.49. Okay, we get this dollar per year. There is a growing rate of your money in the bank after 6 years. So this is the method 1. So another method is simple. We just directly multiply the rate of change, which we initially denote that dy over dt is equal to this one. Okay, we're going to use this one. This already represents the rate of change, which is r times y, which is r times y. So r is 0.05, the growth rate, and y is the amount that we get after 6 years, which is this amount, right? So multiply with this 1349.x6. That will give you the same answers. Okay, per year. Okay, we get this the same answer per year. So this is C. So next we're going to see the questions, the D. How long is required for the initial investment to double? Okay, so our objective now is want to know the times our initial investments from 1,000 we grow to 2,000, right? So we want 5t, we want find the time, okay, such that our value y of t is grow to this amount of money, 2,000, right? So we're going to substitute to our equations here, y equal to 1,000 exponential rt. So in this case, we want to know the time t. So we substitute y equal to 2,000 on the left side. Okay, so solving this, we have this exponential 0.05 of t is equal to 2. And then we get, with time ln on both sides, we can get the t value out, which is the ln 2 divided by 0.05. And that will be the year that we need to wait so that our investments will grow to 2,000. Let us see the bacteria growth problem. So a colony of bacteria is growing according to the exponential law. The initial size of colony was 100, so the size of the colony is doubles in 9 days. So question 1 determines the growth constant. Okay. So given the information here is that at time t equal to 0, and we know that the initial colony size, which denoted as P naught, is equal to 100. Okay, so P is equal to 100 exponential kt. So we need to find the growth constant k. So we just to substitute the initial conditions into these equations with extra information given here is the size of the colony is double in 9 days, meaning that we have another information, which is this information is respect to the size of the colony. So we know that the size of the colony denoted as P when the time is equal to 9 days, and we know that it's double, that means it's 2 times of initial condition P naught, right? So we're going to use this information, substitute here, now P become P naught, okay? And this 100 basically is equal to P naught. We can rewrite this as P naught and exponential k t. T is equal to 9. Okay, so we can cancel the P naught over here. So what we get? So we get 2 equal to exponential 9k. Okay, so you take the ln side on both, you get ln 2 is equal to 9 of k, and then we know what is the k value is equal to ln 2 divided by 9. Then we get the growth constant is equal to 0.077. Okay, so this is the answers for questions A. Now questions B, how large will the colony be after 14 days? So the colony size is P is equal to 100 exponential. So the growth constant we already find out time t, right? So we need to find what is the size when the time is equal to 41 day. So we substitute into these equations 0.077 times 41. Then you get the colony size, which is 2,350 bacteria we got. Okay, so that is B. So C, how fast will the colony be growing at that time? How fast it will be growing basically is we need to find the rate of change of the bacteria. Okay, how fast, right? So we need to find the rate of change of bacteria. Okay, so the rate of change of bacteria is denoted as dp over dt. Okay, so this dp over dt, this is growth problem, so this is equivalent to kp, right? So that means we know that the rate of change, how fast it grows, dp dt. K we already know from questions 1, so it's 0.077. So what is the rate of change of bacteria at that size? So the size that we have is 2,350. So we time 2,350, and that will give us 101 bacteria, okay, per day. Okay, I mean every day, every 1 day we get this amount of bacteria. Okay, so now we focus on questions D. What time the colony will contain 800 bacteria? So meaning that at what time the P will be equal to 800. So we use the same equations, P equal P naught exponential kt. So we want to know what time, substitute this P equal to 800. P naught is the initial size, time K we already get from the initial value, and time the T. Okay, so solving this, we can find what is the t values. So we have exponential 0.077 t is equal to 800 divided by 100, we get 8, right? And then so from here, we take the ln on both sides. Okay, with the ln on both sides, then we get 0.077 t equal to ln 8, and the time is just ln 8 divided by 0.077. So the t here will be equivalent to 27 days. Okay, so after 27 days, we get the size bacteria is equal to 800. Now we see question E. How large is the colony when it's growing at a rate of 200 per day? If it's growing at a rate of 200 per day, what is the size of the colony? Okay, now we see here. Okay, so when growth, okay, at rate of 200 per day, we want to find out the colony size, meaning that the dp over dt is equivalent to 200, and then we can equal to the rate of change of this kp. So this 200 will be equal to k is 0.077p. So solve for this, we have 200 divided by 0.077. Then we roughly get this amount of bacteria. Okay, in the colony.